We start this with a little bit of new notation. We've seen functions of one variable plenty. We know the definition of a function is that each input has one output. We can have a function of more than one variable as long as we just list the input variables. We still need to make sure that we have only one output for any specified list of inputs. So for example, we could take the area of a rectangle. A as a function of length and width is given by the formula L times W. The perimeter of a rectangle, P, perimeter as a function of length and width, is given by this formula. The main thing that we need to keep in mind when we're using this notation is that order matters. So if the function is defined with L first and W second, then anytime we call the function, we have to make sure that we put L first and W second. That's the only way you can tell which number goes in for which letter. So for example, if we're asked to find the perimeter of a rectangle with length 4 feet, so that's telling me a value of L, and width 5.7 feet, when we use this language, we have to make sure that 4.2 goes first, 5.7 goes second, so that it's clear which is L and which is W. Aside from that, we just plug them in like we would any algebraic expression. 2 times the length plus 2 times the width gets us 8.4 plus 11.4 is going to be 19.8. Since this is an area, oh no, sorry, this is a perimeter. Each of the length and width were given in feet. This is also in feet. We have an application of these two formulas, which is, let's suppose that we want to enclose a rectangular area of 480 square feet. So this rectangle is defined by a length and a width. And we're going to enclose it using 104 feet of fence. Note that we're given a value for the area, A, and we are also given a value for the perimeter, because if we're talking about the amount of fence, that would be the perimeter P. So we can set up two equations based on these two formulas. First of all, the area gives us that the length times the width is equal to 480. And the perimeter gives us that 2 times the length plus 2 times the width is 104. This is now a system of nonlinear equations, so we can solve it using the substitution method. And generally it's easiest if you have one linear equation and one nonlinear. So this second one is a linear equation. The first one is not, because my two variables L and W are multiplied together. So I'm going to start with the linear equation and solve it for either L or W. It really doesn't matter which one. So 2L is equal to 104 minus 2W. Then if I multiply, or rather divide both sides by 2, that gives me that L is equal to 52 minus W, just dividing each of those coefficients on the top by 2. I can now take this expression and substitute it into the other variable, the other equation for the variable L. Doing this results in the following. In place of L, I have 52 minus W. W in this equation stays W, and the equals 480 also stays equals 480. So now I have a quadratic equation in W, which I'm going to multiply out and see if I can solve it by factoring. When I get all the terms on one side, I'm going to choose to move everything to the right in this case because that's going to make my leading coefficient positive. So moving both of those terms to the right changes their signs. I get w squared minus 52w, but that 480 didn't move, so it remains positive. So at this point, I can try factoring. If factoring this is difficult because the numbers are a little bigger, then the quadratic formula is also an option. But in this case, I believe that 12 times 40 does the job. 12 times 40 is 480, 12 plus 40 is 52, and we have the signs all correct to make this work. So we end up with two solutions, w equals 12 and w equals 40. Keep in mind that these are both values of w, neither of them is L, so really I need to plug them into one of the original equations to find L. If w is equal to 40 and 2 times L plus 2 times w, which is 40, is 104, then we end up here with L equals 12 after a couple of steps. If w is equal to 12 and I plug that into 2 times L plus 2 times 12 equals 104, over here I end up with L equals 40 after a couple of steps. So this is one of those unique situations where actually, even though these were both values of w, it would have worked, albeit incorrect, to have just put them together as the dimensions of the rectangle. The reason this came out is that both of our equations were symmetric with respect to L and w, so the equations didn't really care which variable was which. So basically I'm going to choose the one that has width less than the length, because that's the way we usually use these numbers, and maybe throw out this other one and say that the width is 12 feet and the length is 40 feet.